Alrighty. How many questions did we get through of the 4? 1, 2, 3, or 4? Just hold up on your fingers. I know it's early. Are you tired too? Couple? Alright, cool. Well, for A, inverse sine of negative 1/2. There we go. Negative pi over 6 in the 4th quadrant. Is that what you guys got? Seeing some nods, yep. Good. Remember, inverse sine's negative. We're going to be in that 4th quadrant. Our radians on your unit circle is probably 11 pi over 6. But remember, we got to go in the negative direction. We got to go the short way when we're working with the inverses. Arc cosine of root 3 over 2. Is this going to be in quadrant 1 or quadrant 2? 1, yep. Cosine positive is quadrant 1. Cosine negative is quadrant 2. Do we have to mess with our radians at all if we're in quadrant 2? No. Whatever you see, our domain restriction for cosine or any of the quadrant 1 and 2 inverse functions is just 0 to pi. So whatever we already have on our unit circle is good. Arc cosine of root 3 over 2. Is that what you guys got? Positive pi over 6. Good. All right, here it is. Inverse tangent of root 3 over 3. Inverse tangent, we're going to be in quadrant 1 or quadrant 4. It's positive, so which quadrant are we in? Quadrant 1 or quadrant 4? 1, yep. We're in quadrant 1. And our value, well, it's not 1, so it's not going to be pi over 4. And it's not 0 or undefined. So it's either going to be pi over 6 or pi over 3. It's going to be one of those other two. Looking at the value inside, it's root 3 over 3, which is less than 1 because the denominator is the bigger number. Since it's less than 1, since our slope is less than 1, that means that our tangent value has to be pi over 6. Is that what you guys got? If you didn't quite get there, whether you kind of got a slow start or you're struggling, does it kind of make sense how we got inverse tangent there? Good. All right, so this is where, guys, I need you guys to really lock in. These composite functions are going to be really important this unit. Really, really important. The way we do composite functions, and it's probably the most missed thing on the skills check, is we work inside out. It's kind of like when we were evaluating that horizontal or that phase shift when we were graphing. The first thing we're going to do is we're going to take out what's inside of the parentheses. We're going to evaluate the inside. So we need to figure out first what inverse sine of negative 1 over 2 is. The nice thing is we already know what that is from A. We know it's pi over 6. Negative pi over 6. I was about to say negative pi over 6. From there, we take this answer and insert it back into our tangent statement. So then it's tangent of negative pi over 6. And we evaluate that for our answer. What's in the blue is something you guys could have been asked on your Chapter 6 test, or even your Chapter 6 quiz. This is something we learned kind of a little bit ago. Is this the inverse or is it just a normal? Normal. We are given a radian, we're given an angle measure, and we're asking you for, in this case, y over x. Here, at that point...
Good morning, and pardon this interruption. We, the students that are testing this morning, should head to their testing rooms. Thank you.
At that point on our unit circle, remember it's the coterminal angle would be 11 pi over 6. If that's how you need to do it, that's fine. At 11 pi over 6 or negative pi over 6, they are the same thing. Our y coordinate is negative 1/2. Our x coordinate is positive root 3 over 2. Our 2's in the denominator are going to cancel. So then we get negative 1 over root 3. It's a different part. Negative 1 over root 3, which when we rationalize is negative root 3 over 3 as our final answer. If you get this written down, you're going to get half your credit because you did half the work. So make sure, if it's a composite function, you should not just have one thing written down on your sheet. You should at least have the whole thing equals this, which equals that. Because then if you made a mistake on step 1 or step 2, if you made a mistake on step 2, you can still get half your credit because you did half of the process correctly. Show your work, please. Any questions on the bell work? Alrighty. So remember this from Friday. If you didn't get it written down or you weren't here, you need this written down. These are our quadrant restrictions. The underlined ones are the ones we kind of learned on Friday, touched on Friday. Remember, we already know cosine, sine, and tangent. And one way to kind of remember without having to remember 6 individual restrictions is cosine and sine, their sisters are going to be restricted to the same quadrant. And then tangent and cotangent have kind of been our rule breaker. This whole chapter, 2 chapters that we've been on, cotangent is going to be opposite of tangent. It's going to go with cosine. So make sure you have this written down, our quadrant restrictions. All right, so now we're going to talk about how to evaluate the inverse sisters. And there's 2 nice things. One, all of the sister functions are going to follow the same general solving strategy. 2, you guys already know the individual steps, it's just applying it. And here's why. In general, whenever you have a sister function, an inverse sister, we are going to make it equal to just an inverse trig. Cosine, sine, or tangent. And we can do that because we know in general, sorry, not meaning to block you. For example, the sister for cosine is secant. We know that in general, cosine of x over r equals secant of r over x. This kind of follows along with our inverse. Inverse sine of some radian, inverse sine of theta, is equal to inverse cosecant of 1 over theta. The same thing applies. All right, real quick, if you wrote this down, I need to make a little correction. We input coordinates. What's inside our inverses are coordinates. What's inside of our normals are the thetas, or our angles. It's kind of weird. I was thinking about the solving aspect of it. But just in general, the reciprocal, if you take the reciprocal of whatever's inside of a sister, if you just flip the inside of the function, you get your sister function, and it works kind of both ways. So the way we can rewrite inverse secant is, what's the sister for secant? Cosine? Yep. So we can rewrite inverse secant as inverse cosine of then the reciprocal of -2. Remember, we keep the sign the same when we're finding the reciprocal. -1/2. It's pretty cool. We already know how to evaluate this. We spent last week learning how to evaluate that. Pretty much all you're learning how to do today is how to rewrite these inverse sister functions as just the inverse functions that we already know how to evaluate. From there, we're just reviewing what we did last week. It's kind of nice. We have a built-in review day of what we did last week. So take a second and evaluate inverse cosine of -1/2. Remember, that's going to be in quadrant 2, since our cosine restriction. Our cosine restriction is quadrant 1 and quadrant 2. There's a negative on the inside, so that's going to push us to the negative side or the left side of our unit circle for the x. We go over to our unit circle. Cosine is our x coordinate. We're looking for where our x coordinate is -1/2. It's going to happen right here at 2π/3. When we're in quadrant 2, we don't have to worry about flipping around our radians. That's just our answer, 2π/3. So now I want you guys to take a second and try to rewrite number 2. How can we rewrite inverse secant of -2√3/3 as a inverse cosine function? Raise your hand if what I wrote on the board matches what you rewrote in your journal. Good. So is this going to be a coordinate that we see on our unit circle? Is that something you recognize? No. Every coordinate on our unit circle is already rationalized. So this is where we have to be careful. If we rewrite it and it's not rational, there's a square root in our denominator, it will not show up on our unit circle. So now we have to rewrite it again. We have to rewrite it again, but as with a rational inside. The way we would rationalize the inside, I'm just going to write the inside. -3/2√3. You just have to multiply by the square root. So our square root here is √3. You don't have to multiply by the whole denominator. So you multiply top and bottom by √3. And we're going to get -3√3 all over 2 times 3. Our 3's are going to cancel. And we're going to be left with -√3/2. Now, is that something we're used to seeing on our unit circle? Yep. Yeah, it is. So that's going to be one step that you have to kind of be cognizant of, is if the inside is irrational, if the inside has a square root in the denominator, you're not quite done rewriting it. So now this is something we can evaluate, inverse cosine of -√3/2. Are we looking for the x coordinate or the y coordinate? X. Are we looking It's a negative value. Are we looking at quadrant 2 or quadrant 4? 2. Can anyone on this side of the room tell me why it's quadrant 2 and not quadrant 4? It's negative. So, yep. What I was really asking is, what's our restriction for cosine? Is it 1 and 2 or 1 and 4? 1 and 2. That's why we're looking in quadrant 2 for this negative value. Looking at quadrant 2, we're looking for where x is negative root 3 over 2. It's going to happen right there at 5 pi over 6. Got showed up. The only time we have to rewrite our radians in negative is when we're in quadrant 4. So we are good with that answer. I want you to try to rewrite numbers 3 and 4 for me. Take about a minute. Remember, you're not done rewriting it until you're in terms of inverse cosine, inverse sine, or inverse tangent. And the inside is rational.
That's a good guess. I like almond joys, they're good. What's up? What else is inside? A little coconut, maybe?
Almond, coconut. That's a good combo. Coconut, chocolate, slept-on combination. All right. So, rewriting it. What's our sister for cosecant? Sine. Yep. So, do I write it as normal sine or inverse sine? Inverse sine, yep. Trick question. Inverse sine. And then the inside, if you just took the reciprocal, your first step would have been 3 over 2 root 3. It would have rationalized the same exact way. Number 2 rationalized just without the negative. So it would have rationalized to root 3, positive root 3 over 2. The next one is another inverse cosecant. So we're going to rewrite it as inverse sine. And here, what's the reciprocal of 1? 1. What's the reciprocal of negative 1? Negative 1, yep. The way we write 1 as a fraction is 1 over 1. We can flip our numerator and denominator all day. We'll always get 1 over 1. Our sign stays the same when we're finding our reciprocal. So here's just negative 1. Give me a thumbs up if you wrote both of those the same way I did. Give me a thumb medium if you went 1 for 2. Give me a thumbs down if you're like, Mr. Suchi, it's early and I don't understand what's going on. Yeah. I just simplified it. I skipped a step. If you rewrote it as negative 1 over 1 and then simplified to negative 1, that's fine. There would have been an extra step in here. There would have been the step where it was 3 over 2 root 3. But I just kind of skipped it since we already did that work. So inverse sine of root 3 over 2. Inverse sine puts us in quadrant 1 or 4. It's positive, so it's going to be quadrant 1. Anytime that inside's positive for the inverse, we're going to be quadrant 1. It's nice. It's consistent. Sine is the x of the y. Y. So we're looking for root 3 over 2 y coordinate in quadrant 1. It's going to happen right up there at pi over 3. And then inverse sine of negative 1. What do we get for this one? Negative pi over 2, yep. We're looking for where in quadrants 1 or 4, our inverse sine is going to be negative 1, which is our y coordinate, has to be negative 1. Remember, sine, we go all the way to both boundaries and include them. So it's going to be 3 pi over 2. It's in quadrant 4, so we have to turn it into a negative. So our negative, completing the circle, taking the shortcut, however you need to think about it, negative pi over 2. So cotangent is a little bit different. What is the restriction for inverse tangent? 1 and 4. What is the restriction for inverse cotangent? 1 and 2. This is where you can get it can be confusing. Whenever you have an inverse cotangent, I would write down to remember that we're in quadrants 1 and 2. Remember, when we looked at those parent functions for tangent and cotangent, we had to go all the way to the tiebreaker to decide if we were going in quadrant 2 or 4. It turns out our values for quadrant 2 or 4 for tangent are always going to be the same. It's just where are we evaluating? Because then our angles are going to be different. If we're evaluating quadrant 2, and our tangent is negative 1, we're going to be at 3 pi over 4. But if we accidentally misevaluate and go to quadrant 4 for that same tangent or cotangent, we would be at negative pi over 4. Those are two different values. So you just have to be careful. When we're evaluating inverse cotangent, we're going to follow the same pattern, but that inverse tangent at the end, we're going to be evaluating in quadrants 1 and 2. Don't worry, we'll go over that together. So first things first, it's an inverse sister trig function. So we're going to rewrite it. We're going to rewrite it as its sister with the reciprocal of the inside. So here we would rewrite it as inverse tangent. The reciprocal of 1 is just 1. 1 over 1. Flip it. 1 over 1. Inverse tangent of 1. And now that's where we have to hit the brakes, because we started at cotangent. Cotangent, we restrict to quadrants 1 and 2. We restrict to 0 to pi. So we have to figure out where tangent in quadrants 1 or 2 is going to be positive 1. The nice thing for all the positive tangents is that it's going to be the same thing as normal. We just have to think that the negatives, when it started off as a cotangent, we're going to have to be looking in quadrant 2, not quadrant 4. Here, we're looking in quadrant 1. We're looking for where the slope, it's tangent, inverse tangent, where the slope is going to be 1. We get a slope of 1 when our x and our y are the same value. And that happens right here. So our answer is going to be pi over 4. Inverse cotangent of negative root 3 over 3, this is where it can get tricky. Inverse cotangent, we got to rewrite as inverse tangent. When you guys are writing it, you can always write it in this form, but just know on the test, if we ask you arctan or arc anything, that's another way to just say inverse. Here the reciprocal of the inside is -3 over root 3. Can we leave it like that? Yes and no. Yes and no, because the way we evaluate our tangents are we don't look for a specific coordinate. We look for the ratio or the slope. And here, we can tell that the numerator is bigger than the denominator, so we know where to look. That being said, if you're someone who's remembered in your head that the tangents are going to go 0, root 3 over 3, 1, root 3, and undefined, if you're someone who's remembered that, then you better rationalize, because this is not something that's on a normal unit circle of tangents. If you rationalize this, that part right there, I'm just going to erase and rewrite, would be negative root 3 over 3. We're looking for that. Yeah, it's arctan. It's inverse tangent. But what did we start as? Cotangent. We started as cotangent. So what we started at determines our evaluation criteria. Here, we need to evaluate at quadrant 1 or quadrant 2. Is the inside positive or negative? Negative. So we're not going to be in quadrant 1. Quadrant 1 is all positive all the time. So that tells us we need to look in quadrant 2. And in quadrant 2, arctan tells us a slope. Here, our slope, the denominator, is bigger than the numerator. So does that mean our slope is going to be steeper or not as steep if the denominator is bigger? Not as steep. It is not going to be as steep. And that's kind of the way we can think about slope. As slope increases, steepness increases. Looking at our lines in quadrant 2, the not as steep slope from -1 happens right at 5 pi over 6. And that would be our final answer, 5 pi over 6. Your math sense might be telling you, oh, I need to make it a negative radians. No. Our domain restrictions for quadrants 1 and 2 is 0 to pi. 5 pi over 6 is within that restriction. We are good. I know cotangent's weird. Hopefully you were feeling really good about 1 through 4. Cotangent's just a little bit extra. Oh, there it is. Now I would like you to copy down all 6 of these questions. And then for the next 10 or so minutes, work by yourself or with the people around you to evaluate. Are you going to have to rewrite all 6 of these? I know you're copying down real quick. Just a quick question. Are you going to have to rewrite all 6 of these? No. If I numbered these 1, 2, 3, 4, 5, 6, we only have to rewrite 3, 4, and 5. 2, 1, 2, and 6, sine, cosine, and tangent, are already in something that we can easily evaluate. At about 8 o'clock, I'll display the answers so you can quickly compare. And we'll get another crack at it tomorrow during bell work. If you need any help, just call myself or Miss Brian over and we can kind of talk about it.